Alright, so today I'm going to show you how to use Minitab Express to calculate normal distribution probabilities. So this is example 2 from your normal distribution page. It's PDF up on Blackboard. So this is describing an IQ test where it's normally distributed with a mean of 100 and a standard deviation of 15. And letter A asks you if you want to join Mensa. You have to have an IQ of at least 138. Now remember, the phrase at least means greater than or equal to 138. It says what percent of the population can join Mensa. Alright, so the first thing you need to do is really, have a visual of what this thing's going to look like. So what we'll do first is let's go ahead and draw a bell curve. This thing's going to be a little choppy. I'm drawing it in Word. Not the greatest program to do this in, but we're just getting it for a visual right now. So there's your bell curve, and if 100's in the middle, 138's got to be off to the side somewhere. So I'll scribble this in, and you got to envision this thing being shaded in. So the mean's in the middle here. The mean's 100. And then this, this number here for x, which is, what you need to get for, to get into Mensa, this would be the 138. So this question really is asking you this area to the right of 138. How much area is that under the bell curve? Now remember, under the entire bell curve, that's an area of 1 or 100%. But this is the x value here, 138. This is the mean, 100 in the middle. And remember, the spread from center, that's what the standard deviation of 15 is describing. So, believe it or not, getting these answers, in the software packages is very, very easy. Normally, you would have to convert the 138 to a z-score using the z-score formula, and then go to your table of z-scores in the back of the textbook and pull the probability off of it. But in Minitab, it's a very easy function to do. Use our probability menu. And as you see, there's a bunch of choices here. You've already used this cumulative distribution function. You've also already used the probability density function, when we were calculating binomial and Poisson probabilities. I want to choose this distribution plot function. So if I choose the distribution plot function, it comes up with some other choices, one of which is display probability. Pretty plain and simple. You select that, and it's kind of nicely laid out for you. There's only really 4 pictures you'd ever come across, and the 4 pictures are you shade to the right, you shade to the left, you shade on the right and left, or you shade in between. The scenario we're looking at, obviously, is a shade to the right scenario. So in Minitab, I'm going to keep this shade to the right, but we have an x value, so it says shade the area corresponding to the following: a specified probability, or a specified x value. I have an x value. And of course it wants to know, hey, what's your x value? Well, our x value is 138. Now, up top here is how you describe the distribution shape. What is the distribution? All right, well, it's normal. And if it's normal, then it wants to know, of course, what's the mean and standard deviation. Of course, if you pull this drop-down menu and change it to a different distribution, then the input parameters here, they would change, of course, depending on what that distribution required. So the normal distribution requires a mean, which is 100, and a standard deviation, which is 15. So you're saying, I've got a normal distribution whose center is 100, spread from center is 15. I want you to find the area to the right of that x value of 138. So you say, okay, and I've already worked this, as you can see. So here is the output. Real straightforward. It draws a real nice bell curve for you. It labels it up. There's the mean of 100 in the middle. There's the 138. And that little tiny shaded area right there, that's the probability, 0.0056. Typically, we take 4 decimal places. And as you can see, that's where I got this answer here. All right, well, the next question, it's virtually identical. It says, many sociologists consider a child as gifted if their IQ is above 150. All right, so instead of having a 138 here, change that to 150. It says, what percent of the population is considered to be gifted? All right, so change this to 150 instead of 138. You go back to Minitab and rework that probability. So you select distribution plot, display probability. Okay, input the parameters once again, which are 115. I want you to give me an area corresponding to the right of an x value. I'll change that to 150. Now I would imagine this is going to be a very low probability, so you say okay there. And there you have it. You can't, notice you can't even see the shade. It's so tiny, the shade, that you can't even see it. So it is 0.0004, the 4 decimal places. You know, so there's the probability. You want that as a percent. Just move the decimal 2 spots to the right. It's 0.04%. And anyway, what do they want to know here? It says, all right, so it says what percent of the population is considered to be gifted. All right, so you take that thing, move the decimal 2 spots to the right. If a particular school district has 12,000 students, then how many would you expect to be gifted? Well, this percent right here of the 12,000 students. So you multiply those two things together, you get about 5.14 or 5 students. Real straightforward way to work probabilities in Minitab. Letter C, a person who has an IQ of 70 or below is said to have a mental disability. What percent of the population has mental disabilities? All right, well, same deal. Probability, distribution plot. Give me a probability. Normal with a mean of 100. Standard deviation of 15. But this time I don't want to shade right of an x value. I want to shade to the left of an x value. And of course it wants to know what's the x value. Well, the x value is a 70. So you pop a 70 in there, and it's going to give me the area from 70 to the left under this bell curve. So you say okay there, and there you have it. So as you can see, these features are very easy in Minitab. Now say you wanted to work something like this same probability in the TI calculator. You know, the TI calculator is set up to do this. So for those of you that have the calculator, you could do it. If my calculator is going to work today, who knows? Let's see. There it goes. So it's in the distribution menu. So second bars, and here it is right here, normal CDF. So you select normal CDF. And the problem with normal CDF is you have to know how to use it. Unless you have the new fancy calculator, then it prompts you. But the input parameters have to be given in a sequential order in the calculator. So if you want to use this normal CDF function to get this same probability that we got in Minitab, you have to first describe this shaded region. So from an IQ of 0, say, to an IQ of 70. So you tell the calculator that. From 0 to 70, the first two inputs describe the shaded region. Comma, the next two inputs are the mean and the standard deviation. So you would say comma 100, comma 15, and then close the parenthesis. So it's lower bound of the shade, comma upper bound of the shade, comma the mean, comma the standard deviation. And you say enter, and of course you get the same answer that Minitab gives. So the question is, you know, what way do you like better? I kind of like Minitab's output. This is not the only way to do this in Minitab. This probability menu, you can instead use cumulative distribution function, and you can work the probability the same exact way. It's just that when it draws the picture for you, using the distribution plot feature, I kind of think it's a lot nicer. The last part to this was the inverse normal distribution. To the nearest whole number, what's the IQ for the top 1% of individuals? Well, the top 1% of individuals, that's already an area. And that would be up here, top 1%. So when you're working, you know, going backward, this is called inverse cumulative distribution. You could actually do it in here as well, in distribution plot. You could do it either way. Yeah, you could do, you know, the normal with mean 100, standard deviation 15. Give me a probability value. What's the probability? The probability is 0.01. That's 1% of people, right? So it says the top 1%. So if this little shaded region, if that was 1%, what would this x value give? So now the first three questions, we knew the x value and we're getting the probability. This time I know the probability is going to give me the x value. So this is the backwards procedure. So you say OK there. And there you have it, 134.895. That's not the only way to do this question, however. You could also do this using the inverse function, inverse cumulative distribution. Form of input. And it's a single value. The value is 0.99. The thing with this, it's cumulative. Notice the word cumulative right here. If you're going to use this menu, you have to give it the area on the left-hand side. If the area on the right is 1%, the area on the left would be 99%. So this would be 100. And this would be 15. It's going to give me the same answer. It's just that it doesn't show the picture of it. And if you're wondering, how can we put in 0.99 instead of 0.01? Because this function that I used here is a cumulative function. It needs from the beginning to where you're specifying. So in other words, from the left boundary to where you want. That's 99% of the area. It's just what that feature requires because it's cumulative. However, I kind of think it's nicer to use the distribution plot menu, display a probability. And say, all right, I'm going to give you an area of 1% up here. You return me the x, and say okay, and it draws the picture for you and everything. I'd prefer to see it that way. So I put a 10 here instead of 100. That's why it's a little off. We'll recalculate that. $115, and this is 1%. This is the correct version. 134.895. I called it about 135. All right, email me if you have any questions.